All right, the previous video introduced what we call the imaginary unit. When we involve imaginary parts to our numbers, we end up with this new number system, which was called the complex number system. And if you look at the hierarchy of number systems, right, this complex numbers sort of lords over everything. In other words, a different way of saying that is that everything is a complex number, okay, or can be expressed as such. So complex numbers look like binomials, right? They look like a two-termed expression. This is really one number, okay, that comes in two parts. We have this leading part, which looks like something that you're familiar with. This is what we call the real part, and this is always a real number, right? Now, real numbers used to be sort of the overlord of the number system, right? Real numbers could be broken into rational and irrational numbers, and rational numbers could be broken into integers, okay, and so on and so on. And integers could be broken up into whole numbers and yada, yada, yada. So, real numbers was sort of like every number that we could imagine. Get that? Right now that we've introduced imaginary numbers, now the complex number system sort of has taken over the crown of real numbers, okay? So we have the real part, and then we have this second part which has the I attached to it. This is what we call the imaginary part, okay? Now, like I said before, every number can be expressed as a complex number. Like even the number 2 is a complex number. It just has 0 as its imaginary part. Okay. And the same idea, if you have, 4i's already been used, but we'll use it again. If you have 4i, this is a complex number. It is 0 plus 4i. So we can add that 0 part for the missing piece in this number. Okay. But a lot of our complex numbers are written like so, and I will tell you that I got in the habit a while ago of writing my complex numbers with Z's. Sometimes they come with subscripts. Okay, this comes from my time taking a complex analysis course in college. You see this very often. A complex number, right? The variable that we use to express it is Z, right? In the real number system, if I said pick a variable, you would say X. A lot of people would say X, right? In the complex number system, we use Z for our variables. Okay, let's move on to this next part really quick, and that is the complex plane. Okay, the complex plane, and again, there's a video out here that I'm going to attach to my lesson. It's out there that explains what the complex plane is. It's actually sort of a third dimension, right? And it's really hard to express on a piece of paper two-dimensionally like this because you're used to looking at a coordinate axes like this and say, well, that's X and that's Y. Okay. And that actually helps us in this instance when we want to graph things two-dimensionally. Okay. When we graph a complex number, the x-axis is called the real axis, and the y-axis is called the imaginary. There it is, the imaginary axis. Okay, and it helps if you view this because our complex numbers look like they come in two dimensions already. They're a two-termed expression. All right, a plus bi gets graphed like a comma b. So for example, if I had a complex number that I'm going to call Z, and that was 3 minus 4i, we had that in the previous problem, the real part is 3, the imaginary part is negative 4. It's almost as if we're graphing the point 3, negative 4, okay? So we would put that point here. But when we express it, we write it as this complex number. Okay, so the complex plane, it's very similar to the real number plane. We have to redefine the two axes as real and imaginary, but we can use this complex number as a regular ordered pair of x and y if you want, if it helps you visualize it like so. Okay.